Okay, so our final speaker in this session is David Wayne from Turing.com. And David was a PhD student graduating in 2006.
Okay, thanks. And thank you, Stephen. Happy birthday. And this is when Legion asked me to see if I can talk about my work. I was talking about this very shallow because it's still very, very early, and it's intended to be an appetizer for the lunch. So, and and first, I would like to introduce a bit myself. In 2001, I joined Caltech as a NetLab, and Stephen had been my professor for the whole time. And when I graduated, Stephen actually gave me advice, like, you have to build the biggest thing in the world, no matter it's actually a system or whatever. And because I'm not that good at my theory, but I can build things. And actually, Professor John Doyle, I remember he gave advice, he said, you either go to be a professor or do a startup. And I kind of found it's really hard. So if you look at my trajectory, it's kind of, I'm switching back and forth. So I joined Stephen's startup in FastSwap, and then after that, I spent some time in Google to do high-performance network. And in 2008, I joined Facebook. At that time, it was still a startup. So, but then we actually built the biggest network in the world, in the social network. And also a lot of things like user growth, internet connectivity, and also social impact, integrity, experimentation, and all the things. And then since last year, I started to actually, hey, now we are already building one of the biggest things, and I go back to startup. So now I'm going to talk about Turing. And Turing is a very interesting company. I will talk about what we have later, yeah. Cool. And so the topic of this is very shallow and very simple. We are kind of accidentally walked into the LLM fine-tuning space as a company. I can give a very, very quick introduction to Turing. At the beginning, it was started as a company to find the remote worker around the world. All of them are software engineers, and then work in American company remotely. And during the pandemic, they do a lot of good work, and then a lot of remote work, and a lot of engineering hiring speed, so they do well. But in 2022, they get an email. Actually, it's very early 2022, before ChatGPT, everything's coming in. They get an email from OpenAI, just code, like, can I hire a few engineers? And then they start to hire the engineer. And then at the end, they hire hundreds of engineers. And no one knows what's going on there. And later, we actually found out the rough idea about what's going on is like, when the large language model is getting to the point, that model capability start to be, in some area, comparable to human being. The traditional training data that we use for machine learning is no longer valuable. Like when we say traditional training data are things like, is this a laptop? Is this a cap? And those are things in the past is actually very valuable to actually train the model. And if you train this kind of simple labeling process, it's actually pretty easy. And you can actually build a very good product. And sometimes you use machine learning to actually assist. And then you actually make the labeling really, really effective. But when you get to the point that the model has some capability are comparable to a human being, you can't actually have this kind of labeling. You need to actually hire the really good people to do it. You need to express in a way that is not so simple, yes or no. And that becomes a challenge. And I think now it's more open. Like OpenAI actually is probably one of the first they actually realized that. And then suddenly in 2023, end of 2023, suddenly everyone actually figured out, like Anthropic, Google, Meta, Apple, Snowflake, they all actually are working with us at this moment. I'll talk a bit more about what are this work, what are the training data in this kind of LLM space. So we start with actual code generation. Very simple. If you give me a function, can you actually write a code? And that basically becomes the Copilot product. But after that, it's also interesting to find that the same methodology can actually be solving simple math problem. Like the very famous rabbit and chicken problem. Like usually in the past, when you train the model, if you use simple labeling, what we'll do would be the question would be given a room with 10 rabbit and chicken, and you see 30 fish, how many rabbits are there? And the trainer will tell you, it's in this case, probably is a 5 rabbit and 5 chicken or something like that. So they will give you the answer. But the way that you want to train the LLM more effectively is actually to ask the LLM to give you why. And basically the last sentence, the underlined, can you explain in code? And once you actually ask that question, somehow, still there's no scientific here. That's why I think it's more like appetizer. Somehow, it seems that the label becomes much more effective. And then you can actually train the model much more effectively. Because you can actually look at the code, and that's actually one of the observations that we see. And I think in general, OpenAI actually have the paper called How to Use Process Supervision to do Mathematical Reasoning. But it's still it's not really scientific. There's no equation at all. So after this first step, what we see is also the same approach that you use code-like language to provide logical reasoning for LLM as a training data, work for other space, similar space like data analytics. Like in this case, use SQL as the programming language to provide the data to LLM. And functional calling is basically you are using REST API-like language to actually provide the reasoning to LLM. And now people start to think about, can you actually do hardware design? And there's a paper, again, it's a Verilog. Can you use a Verilog to articulate the hardware design? And use Verilog to actually train the LLM to actually make sure that they can actually design some of the hardware pieces. So it is still extremely early, and honestly, we are brainstorming with everyone, and we don't actually know why. Why, if using code-like language, can be more effective. So it's probably also a reason I come here to actually share this. So if there's any advice from the best talent in the world, I would love to learn. But there's a hypothesis in my mind that whether programming language is the best best format to train the LLM on, at least on logical reasoning area. And I don't know. And if yes, and how do we actually think about that? So that's roughly what we learned so far in the last year. And there's definitely more question than answer. Like, the first thing is that to what extent this approach can work. Is it only the thing that can be expressed in code? Or is there any logical problem that we can do it? And then the second question is, what's the intrinsic value of this approach? Is it the format of the code itself so that the large language model can be easier to actually digest and can find a segment of the code and then can connect to the natural language segments? It's not sure. Or maybe it's actually just the logical thinking of the engineer that are actually trained to be very structurally think about that. And the training is that come from coding. But the actual coding format may not be matter. Not sure. And then the last one, which is even more fascinating to me that we don't have a good answer, is actually, in the long run, the chance seems to be the LLM will have certain area that have capability better than the trainer. And at least better than the individual trainer. And we can use the LLM to teach the trainer to be better on those areas. But at the same time, you can still use the engineer who is training the LLM to actually teach the LLM things that they don't know. And I can give one example. In the past, we have been using English speaker to train, write code to train the LLM. But you can actually find that if non-English speaker, they can actually use LLM to do the translation of English. And then actually still can write code. And then it's still effective. However, there's also a risk that if you get to the point that some of the area that are actually, we introduce a mistake to the language model, that might be a positive feedback loop. The same example, we have been using some of the second non-English speaker to actually train model. It works well for a while. But after a long time, we actually found that the model starts to actually speak less fluent English. And then where is that point, and what is that positive feedback loop? Is the question that we also don't actually have a good answer. I think that's probably all the thing I have. Because it's super shallow, because this is a new thing. That there's two learning here that I do want to share. One is that by working on this project, I get to work with many, many engineers around the world. And I do feel we are very lucky, seriously. I'm feeling like it's more like Google button, but I have been working with one engineer from Gaza City. He's still working in a safe house. I've been working with people run away from Russia. They are now refugees in South America, traveling between 3 countries without a visa. And they're still working really, really well. And some people they are national Olympic champion, and they just don't have a safe place. And the fact that we can work happily in California is just feeling lucky. And that's something I was not able to appreciate when I work on Facebook. The second thing I do feel really learning is also the internet access and education is among one of the great equalizer. When I talk to some of the engineers in Turing that are working from very remote country in India, one of the things I ask, like, how do you actually get the connectivity? And they say, hey, because in the last 20 years, the internet is actually better and better. And 10 years ago, their project to actually drive down the costs, and happened to be one of them is actually I built that for internet access. I helped that. So once they have the internet access and they have great education, there's a lot of human beings that are really, really good, that have high potential, and we can actually leverage and empower their potential. So in this sense, I really feel lucky in another way that I can follow Stephen to actually work on both these things, internet access, from how to actually make the internet stable in the long distance, and then how to actually make it cheaper in Facebook, and then now actually leverage the actual result of it is people actually get empowered. So that's my quick talk, and happy birthday, Stephen. Thank you.
Have any questions for David?
Please on.
So that last bullet you had up there,
Yeah.
isn't that just because it's making all Americans more stupid? Anyway, well, we can talk about that later.
I would say there's more people smart in the world, as smart as I guess, if they have the opportunity.
Thanks. Since you have the first-hand experience of working with LLM for reasoning, like logical thinking, I'm just curious, from your experience, do you feel probabilistic model is the right model for AI to develop this ability to think logically?
So I think I'm very shallow on that side. So to me, this is more like a philosophical question because there's no explanation here. And if you ask me philosophically based on what I see, actually, go back to Stephen, what he teach me. All model is wrong, but some is useful. And I think this large language model is useful.
I see.
Yeah.
Thank you.
Chen.
So my question is, do you think AI becoming powerful is a equalizer or a risk?
I don't know. It's really, really hard to say. Yeah.
I think that's more than an appetizer. Okay, let's thank all the speakers and move the metaphor.